La Nina emerges. What's that mean? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, March 10th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. To subscribe, just click the Stormsurf icon down in the lower right-hand corner of your screen. And also, if you'd like to make a contribution, you can. Hit the special thanks button down below, the heart with the $sign on it. Make a small contribution. It helps the cause. And with that, I'd like to thank the folks that donated last week. Our regular donators, Our Predicament, Evolution Moto, Coach Nate, Elliot Harris, PPM 0624. Thank you guys very much. Or ladies. I'm not sure who everyone is, but I'm making some assumptions. And then also Don Mendatron and Luke Epstein. Thank you for your generous contribution. We appreciate it. And with that, let's get on with the show. We'll start by looking at significant wave heights for the North Pacific Ocean. Remnants of a gale off the North California coast are still producing 22-foot seas aimed directly at Northern California, and the outer buoys are starting to register that incoming swell. Also, another gale pushing over the North Dateline region with 29 to almost 30-foot seas aimed off to the east, and yet another gale developing off Japan. A productive pattern appears to be in play. But first, let's take a look at current conditions. We're going to start Northern California, just north of the Golden Gate Bridge, Point Reyes, buoy number 029. We're looking at all the energy that's hitting this buoy from all the way up at 33.3 second period, really long period energy, all the way down to 5 second period, basically wind chop. We see where you see the bumps is where the swell is, and it's kind of a jumbled state here. The peak energy, 12.5 seconds out to about 14 seconds, so there's some swell hitting there. We also see bits of energy 16, 18, 20, 22 seconds. So there is some longer period energy trying to push in as well. But we also have a healthy dose of lesser period, not ground swell, but just basically wind swell in the mix as well. So what we do is we try to decipher what is swell and what is wind chop, and our algorithms say primary swell is 9.4 feet at 13.3 seconds from 294 degrees. That would put surf at about 12.4 feet, and there are definitely some large sets that have been building through the day. There's that swell right there, and 12 feet is probably even under calling a little bit. And then there's all the wind swell, 8.6 feet at 10.3 seconds, which makes for an 8.8 second or 8.8 foot bit of surf theoretically, but that's probably all mostly lost under the longer period ground swell. Then we do the same thing for Southern California. We go down to buoy 191, the Point Loma South buoy. That's there off of San Diego. A little bit different profile here, but you still see a bit of energy the whole way from 28 seconds, the whole way to 5 seconds, with most energy focused somewhere in the 15 to 16 second period range. Primary swell, 2.1 feet at 14.9 seconds from 200 degrees. So some southern hemi swell hitting, theoretically making surf about waist high, 3.1 feet, with secondary swell 1.5 feet, 11.4 seconds from the northwest or west really, and that's only not even 2 foot surf. And then finally we go to the north shore of Oahu, Waimea Bay, buoy number 106, and we see a different profile, but still a bunch of wind swell, a little bit of swell, and some other energy mixed in. Pull all the data out of that. Primary swell, or the largest swell, 4.3 feet at 10.3 seconds from 282 degrees. That's about 4 foot Hawaiian surf, we'll say, maybe sets in the head high range. And then wind swell, 4.2 feet at 6.5 seconds. North wind swell, waist high, thigh to waist high, and that's about it. All right, so what's been going on in the North Pacific and what has created the waves that are currently hitting? Well, we're going back to Wednesday, the 6th of March. A gale developed over the North Dateline region right there. That's the Aleutian Islands, Northern California here, Hawaii down here, Japan over there. That gale built with 30, well, you can see it right here, 31.7 feet. These are the highest seas over this entire domain. Seas to so 31, we got to 32 feet, and I think that was about all we did, and this was on Thursday, the 7th of March. That system then faded. Another system, and that swell from this system is hitting today, but already starting to be overrun by yet another swell. At the same time, another gale developed on, we'll go back here on Friday, the 8th of March with 41 foot seas. Small swell is radiating off to the east towards Hawaii and the U.S. West Coast, but it's going to be completely buried in yet other swell. And then on Saturday, a new gale developed here in the Western Gulf with 30-foot seas building to 32 feet, and then 30 to 31 feet on Saturday night. And Sunday, today, this system off the U.S. West Coast, swell from it, pushing off to the east, bound for California, mainly north of Point Conception. Now let's go back in time. Yet another system developed on, we'll call it Saturday, off of Japan, lifting northeast with seas at 35 feet. Did we get higher in that 35.9? No, that was it. With a swell from that on the way and more behind that. So we are in a productive pattern for the moment. So what is to come? And we start by looking at the jet stream, because the jet stream really is the source or the beginning point for any gales. And of course, gales produce wind, and that produces surf. So we start at the jet stream. These are winds up about 30,000 feet. They help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet, like right here. And what that does is help create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds impart energy to the ocean and generate seas. Seas, as they radiate away from the fetch area, get groomed out. The shorter period elements fall off and expose swell. And of course, swell, when it hits your beach, turns into surf. So we have a little trough here. We also have remnants of a trough for the gale that's making the swell that's hitting the outer buoys right now off of the Pacific Northwest. The jet is consolidated from Japan out to about the dateline, and then it splits. And when you get this split kind of jet stream flow, you get high pressure in between. And this is sort of typical of the inactive phase of the MJO. Those of you that follow this channel know that the inactive phase of the MJO doesn't do a whole lot for storm production. That said, things are changing, and you'll see as we get into this. On Monday, the jet consolidated, pushes past the dateline almost to a point north of Hawaii. New trough starts building. Actually, it's the trough that it was off Japan. Starts building just west of the dateline. New little trough up here in the Gulf of Alaska. Probably doing nothing but producing weather for the Pacific Northwest as we get into Tuesday. But then the jet and its associated trough as we get into Tuesday moves over the dateline, looking really good, but then starts pinching off as we get into Wednesday. You can't get a good round circulation with a pinch trough like that. And so that will sort of hamper low pressure development. Notice the big split here over the U.S. West Coast. High pressure likely off the coast. This backdoor trough here, potentially bringing some rain and moisture into California. And if this is low pressure and this is high pressure out here, that likely signals a pressure gradient and a bunch of north winds. So we'll keep our eyes on that. Anyway, as we get into Friday, now the consolidated jet is to make it the whole way to a point north of Hawaii, maybe a little bit further. And notice the jet starting to fall south. This is good. And you have a generalized trough there, a generalized trough there as we get into Saturday night, a week from now, the 16th. And that continues holding, if not building, as we get into Sunday night, the 17th of March. So some decent potential here with all the swell production, just looking at the jet stream, somewhere in the dateline region, and high pressure in some fashion over the U.S. West Coast. Not a bad setup. But it takes winds blowing on the ocean surface to produce surf. So let's go take a look at surface level pressure and the surface level wind charts. Here we are, Sunday the 10th of March. We know we have some sort of a low pressure system up here in the Gulf generating 35 to almost 40 knot winds. Another low pressure system off Japan. There's some sort of a double trough pattern setting up there. So we get into Monday. A gale develops in the Gulf with 40 knot winds. A storm develops on the dateline with 50 knot winds. 50 knots is the minimum threshold for to be classified as a storm. This system continues into Monday evening. So we get into Tuesday, low pressure moves into the Pacific Northwest. The storm over the dateline fades to gale status with 45 knot winds. And then in the evening to 40 knot winds. New system builds off Japan. By Wednesday, we still have 35 knot winds aimed directly at Hawaii and a 45 to 50 knot winds just barely off the Kuril Islands, and we're only 72 hours into the forecast. So we go through a little bit further. Things back off for a little bit as the jet tries to reorganize, but then here we are Friday night, 1, 2, 3, 4 low pressure systems of some kind trying to get organized. Now a little bit fragmented, but it all seems to be circulating around a central point right here on the dateline as we get into Saturday night with 45 knot winds again aimed at Hawaii and the U.S. West Coast, pushing towards the northwestern Gulf as we get into Monday night and fading some with yet more low pressure building off Japan. So for the moment, it looks like a decent pattern is setting up with more energy behind that supported by a consolidated jet stream. Let's go look at the effects of these winds on the ocean surface. And here we go. As we saw before, 20-foot seas off California getting ready to slam into the coast. Another system of the North Dateline with 30-foot seas, 29 to 30-foot seas. That system pushes into the Gulf on Monday, still producing 27-foot seas and fading, while yet another system starts building over the North Dateline region with 36-foot seas aimed off to the east and falling southeast, targeting Hawaii pretty well and the U.S. West Coast, but from a pretty good bit away. And yet another system builds behind that off of the Kuril Islands with 38-foot seas. Whoops, we got to, 38-foot seas is as high as it got. Now, this system doesn't make it very far off to the east, so very distant swell for the U.S. West Coast. Probably a better shot for Hawaii, and we're into Friday the 15th of March. And then we know we have multiple small systems. Do they get traction on the ocean surface? Well, all these to the east, not, but the system theoretically off the Kuril Islands, let's just look here, 38-foot seas, 38-foot seas, and then 37-foot seas into Sunday morning, the 17th of March, and then fading, but still hanging in some degree over the North Dateline region. So, again, potential seems likely. Let's drill down to the local wind forecast. California here, that'd be Point Conception, Monterey Bay, San Francisco right there, Southern California down there. Hawaii here, high pressure in control relative to Hawaii, driving strong easterly trades at 20 knots, where the storm pattern somewhere is along the 35-degree line. You already see southwest winds pushing into northern California. As we get into Monday, a slack wind pattern, at least in the morning, and then you see the beginnings of a front trying to work its way into California or we'll say the San Francisco Bay Area, into Monday morning, maybe holding from, we'll say, Point Reyes southward with west to northwest winds, but strong southwest winds into Cape Mendocino. Trades for the Hawaiian Islands. As we get into Tuesday, a light, 10-knot northwest wind regime for North and Central California. Trades start turning more southerly, southeasterly, 15 knots for the Hawaiian Islands. That's preferred, but then as we get into Friday, here comes your high pressure. Nuki northwest winds, at least for the moment, for California. And you see the beginnings of some sort of north wind event trying to set up on Wednesday for the Hawaiian Islands. Not too strong initially. As we get into Thursday, that north wind pattern tries to hold on for North and Central California. Here's low pressure, high pressure here, resulting in a pressure gradient and north winds into the Hawaiian Islands on Thursday. Now notice the winds start turning offshore as we get into Thursday afternoon for North and Central California. And then slowly the winds start clocking around to northeast on Friday for the Hawaiian Islands. Still probably not good. Lighter wind regime for California Friday night. Saturday, basically dead winds for California. Back to super light trades for the Hawaiian Islands. Sunday, a light northwest flow for California and light trades for the Hawaiian Islands. And things settling down a little bit. Precipitation forecast for California. All right, Sunday evening, you see it right here. Precipitation and cold temperatures and a front working their way down the California coast. Rain into San Francisco by 10 o'clock Sunday evening, and maybe down as far as Monterey Bay first thing Monday morning. And snow for the Sierra. All that, though, quickly clearing out. Another front right behind it, though, as we get into Monday night, into Tuesday morning. You see some snow for the Sierra, rain down to maybe Monterey Bay. Oh, maybe even sprinkles down to Morro Bay midday Tuesday. And that all clears out. Here comes your massive high pressure building in. And after that, that is pretty much it in terms of precipitation for California. I'm not going to get into the rain and snow totals, but suffice it to say for California, we're pretty much somewhere between the 85 and 100% precipitation. Up here in the San Francisco Bay Area, we're maybe 2 inches short of being 100% of normal. Southern California has actually been the big recipient of this El Nino winter, getting 100% of their rainfall, and I think even Central California has done equally well. The big storm last week, when was it? Last weekend, actually, that produced, so the models were forecasting, was it 96 inches of snow, something like that, for the Sierra, and that's pretty much what they got, anywhere from 92, 96, depending on where you are. That pushes the snow totals up to just about normal for this point in the season, and this is pretty much past the end of meteorological winter for the Sierra from a snowfall perspective. If we get another 2 feet or so of snow in the Sierra, I think they're going to end up being normal. It seems like that's entirely possible depending how quickly the high pressure system blows out here over the Sierra. We'll keep our eyes on that. We think it will not last too long because of what's going on with the MJO, and we'll get into that in just a minute. But for right now, pretty much normal precipitation for California, normal snowfall, all seems likely. And for a moderate to strong El Nino, that's probably about normal. And during actual El Nino winters, you don't get above normal precipitation unless you're into the super El Nino category, which we are not. Snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. Projected snowfall amounts all on Monday and Tuesday at about 9 inches, something like that. Let's check some other resorts. Kirkwood forecast to get about 7 inches. And unfortunately, Mammoth, maybe half an inch. And this is more, again, one of those north to south falling systems. Just like the last big blizzard storm, all the energy really was focused on Tahoe. By the time it pushed south to Mammoth, most of the precip was wrung out. That's not to say that Mammoth didn't get some good snow, but it was maybe 50% of what the Tahoe area got. And then we look at the snow level forecast for Palisades, Tahoe, representative of the entire Tahoe basin. This is basically lake level here, 6,200 feet, the base of Palisades, Tahoe. The summit up at the top of Granite Chief and Palisades, about 8,900 feet, so right there. Red would be, if there was precipitation, it'd be liquid precipitation. The gray would be sleet. The 32-degree freeze line is right here between the gray and the white. So you see freezing temperatures all down below the base and below lake level down at 55,000 feet to 5,200 feet into the 13th. I think that is Wednesday. Little warm up there, but still basically holding. But then as we get into the 14th, that'd be Thursday, you see the freeze level starting to go above lake level, above the base at Palisades, up to almost 7,000 feet on Friday, and after that a big warm up with the freeze level up at 10,000, almost 10,500 feet and holding. So a big warm up. The hope is that it doesn't last too long and we don't get into some sort of a snow melt situation. I don't think that's really going to happen. But if anything, if this lasts for a week or so, you could end up with actually good spring corn snow skiing conditions. All right, let's go take a look at the projected surf forecast for a couple locations. Start in Northern California, Ocean Beach, San Francisco. Surf on Monday, 14 feet. Might be bigger than that. Based on what I saw in the outer buoys, at least a big front-loaded spike on the swell. 14 feet is probably on the low side. You see the wind forecast, light west at 3 knots at about mid-morning, so that would be a good time if you can handle that kind of surf and you can find the right location to surf at. Another swell coming in on Wednesday in the 12-foot range, but when you see these dropouts, it typically means a bunch of wind swell. And looking here, we're looking at northwest winds at 20 to 25 knots, so pretty much a mess. And then as we get into Thursday, surf settles down into the 5 to 6 foot range and the winds turn northeast at 15 knots or so. And then as we get into next weekend, Saturday, 5 to 7 foot surf and sort of a offshore flow Saturday morning and sort of a lighter moderate northwest flow as we get into Sunday. Let's go look in Southern California. We're just picking San Diego at random. Wave heights, 2.5 to 3 feet into Monday night into early Tuesday, then dropping off, then again in the 2.5 to 3 foot range Wednesday and Thursday. Winds so not so much an issue, but then you start seeing these dropouts. But winds not that bad. And then as we get into the weekend, 1.5 to 2.5 foot surf. And then to Oahu, the North Shore. Right now, all the energy focused at the U.S. West Coast, California, mainly north of Point Conception. So surf heights, 4 feet dropping to 2 feet on Monday, and then toggling in around somewhere the 3 to 4 foot range on Tuesday and Wednesday. But then new swell arrives with wave heights up to 19 feet on Thursday afternoon, and then so slowly trickling down through the weekend. You see the trade wind situation there Thursday, Friday, Saturday, but then you see that little bit of northwest winds on Wednesday. Pretty much looks like it's limited to, Wednesday and Thursday, and then it's finally Friday that we get to the more of a trade wind type situation. Let's go look longer term. What's going on with the MJO, the Madden-Julian Oscillation, and the El Nino Southern Oscillation? These two oscillations are the major influencers of weather from a surf perspective and rain perspective relative to the U.S. West Coast and the Pacific Basin. We start by discussing and analyzing the MJO, or potential for the active phase of the MJO. There are two phases of the MJO, the Madden-Julian Oscillation. Active phase and inactive phase. The active phase is our friend. It is a low-pressure system. The inactive phase, high pressure, doesn't do much for storm production. The MJO, active phase is on one side of the planet, inactive phase in the other, rotates west to east around the planet on the equator. When the active phase moves into the West Pacific, it dampens trade winds. That allows warm, moist air at the ocean surface to start being lifted aloft, being sucked up by the low-pressure system up into the upper atmosphere. That imparts energy to the jet stream. A stronger jet stream does not split. It consolidates like what we just saw on the charts, and then that helps support gale formation. And then the active phase of the MJO moves across the Pacific from west to east, and as it does it, it brings the storm track closer and closer to California. And if the consolidated jet and the active MJO is strong enough, the consolidated jet will push right into California. That's how you typically get those atmospheric river events, formerly known as the Pineapple Express. They teleconnect with warm, moist air down south and the jet stream and make all kinds of havoc in California. Now, seeing how we're already into March, I would not expect that the jet stream would be strong enough and consolidated enough, even in an El Nino winter, to yet make more atmospheric river events relative to California. But we'll see. Maybe some energy will result. All right, so we're looking for signs of the active phase of the MJO. What I did say is the active phase of the MJO dampens trade winds. So we're going to start by looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they have wind sensors on them. This is the East Pacific here. This is the West Pacific here. That is the equator right there. That is New Guinea there, date lines roughly there. We're just looking at the arrows. The arrows and the length of the arrows indicate wind speed. So winds out of the east, moderate over the East Pacific, getting pretty strong over the Central Pacific, and pretty strong over the all-important Kelvin wave generation area in the West Pacific. But it's not the actual wind speeds, it's the anomalies, difference from normal for this time of year. We see winds are out of the east, not exceptionally strong, but a bit out of the east. Then we go to the Central Pacific. There's couple of arrows that suggest maybe a weak pocket of westerly anomalies here, north of or south of Hawaii. But then as you get into the all-important Kelvin wave generation area, winds modestly out of the east, stronger than normal. All this smells of the inactive phase of the MJO. Next up, the 2-week zonal wind anomaly forecast, just like what we looked at. Are the winds stronger out of the east or stronger out of the west than normal? The blues are stronger easterly anomalies, typically associated with the inactive phase of the MJO. Oranges and reds are westerly anomalies, typically associated with the active phase of the MJO. But let's get ourselves oriented here first. This is the whole planet on one chart. Date line runs right up the middle. The far east equatorial Pacific would be Ecuador, starts at about 80 west, so right about there. But the all-important Kelvin wave generation area, the West Pacific, this is where when the active phase moves over that part of the Pacific, it really starts doing its magic with imparting energy to the jet stream. The far West Pacific starts at 125 east, so right there, and goes to about 170 west, so right here. All right, so we can see past performance here, and you see easterly anomalies. Right here is today. Easterly anomalies, inactive phase of the MJO, building over the Kelvin wave generation area with the active phase of the MJO back in February, sliding out of the picture. The good news is, yeah, we are going to have a pretty good easterly wind blow here for about 5 or maybe a week, let's say 5 days to a week. But then, look at this. the active phase of the MJO and its associated westerly anomalies start showing up about a week from now and do a pretty good job of filling the Kelvin wave generation area for the second week of this forecast. So whatever downside we're in right now, it shouldn't last too long. And you literally saw that when we were looking at the Jetstream charts. Remember, the Jetstream was all split and like all the way to the date line. But a week from now, you saw it consolidating with the split point moving east to about a point north of Hawaii. That is reflecting just the first half of this. And as the active phase builds, and we'll see some other models that suggest this might even be a bit of a not optimistic forecast, that the jet stream might consolidate, push even further east. So let's dig more. Next up, outgoing long wave radiation forecast for the next 2 weeks, 15 days. This is another component of the MJO. Remember I said the MJO acts as, or the active phase is a low pressure system. Well, low pressure systems create clouds. The inactive phase, a high pressure system. High pressure typically means clear skies. All right, so let's first look at this chart. Here is South America, Central America, Hawaii there, New Guinea there. Equator right there, the date line right there. The oranges and reds in this chart are dry air, more sunlight reflecting off the ocean surface, loosely meaning the inactive phase of the MJO. Blues are very cloudy skies, and that would signal the active phase of the MJO. So we see the inactive phase over the Kelvin wave generation area. So right there, it starts 125 east out to about 180 west, 170 west, 5 degrees north and south of the equator. So right now, we are inactive phase exiting, active phase coming in. According to this, the statistic model, 5 days from now, active phase sets up over the Kelvin wave generation area, builds 10 days from now, and strong filling the Kelvin wave generation area 15 days from now. Now, this is a statistic model. The dynamic model, though, look at this, basically paints the exact same picture. Yeah, on day 5, the active phase isn't moving quite as quickly. Let's see if we can get both of these. No, you can't see it. This shows the active phase a little bit further east than the dynamic model. But either way, after about a week from now, from 6 days to 10 days, active phase in control, and 11 to 15 days out, active phase in control. So the two models are in agreement. Then we dig a little deeper. These are phase diagrams for the same two models, statistic model here, dynamic model here. What this does is show you where the active phase is and how strong it is. Now, how do you read the chart? Well, the active phase and inactive phase moves from west-east, from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. So this stuff here is all showing you where the active phase was back in February, and then here's the beginnings of March. The heavy dot is where the active phase is right now, so starting to move over the Maritime Continent. And the further that heavy dot right there is from this circle, the stronger it is. So a moderately strong active phase moving over the Maritime Continent. Per the statistic model, there's 3 different model runs here. 2 of the members say moving into the West Pacific 2 weeks from now and very weak. But one member says very strong over the West Pacific. That would be interesting. The dynamic model, the GEFS model, shows the active phase moving into the West Pacific. We can count the days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 days from now, and fading from moderately strong status to fairly weak status. So 2 models somewhat in agreement and suggesting a rather promising pattern starting about a week from now. Next up, we go to an upper level model. This is a statistic model showing areas favorable for precipitation. The greens, wet air, active phase of the MJO. Oranges, dry air, inactive phase. So this goes out 40 days right there. We'll start at the top though, and let's get oriented. South America, Central America, New Guinea there. There's the equator. Dateline roughly there. So you see wet air, active phase of the MJO over the Maritime Continent today, moving steadily through the West Pacific through about the end of March. So March looks like a target for swell production. And then and notice as the active phase pushes south of California, somewhere here, late March, early April, and this runs about a week ahead of what's going on at the surface. That's when you get good potential for precipitation into California. So maybe our last shot at some really solid precipitation would be somewhere late March, early April. Anyway, then comes the inactive phase behind that, dry air and shutting everything down, both the jet stream and the storm track and precip for California. Let's go look at another model. This is the CFS model, and this one goes out a month. This is 850 millibar zonal wind anomalies. And let's get ourselves oriented. Again, the whole planet on one chart. Dateline runs right up the middle. Far West Pacific starts at 125 east right there. Kelvin wave generation area ends about 170 west. The blues are easterly anomalies associated with the inactive phase of the MJO. The reds are westerly anomalies associated with the active phase, and you can literally see MJO is the black line. Solid contour is the active phase of the MJO. Notice the westerly anomalies associated with this. This is back in December. Inactive phase showed up for the month of January. Active phase then followed in February, right here. And then here is our current inactive phase, which is, I'd say, almost past its peak. We're in the last hurrah, the last week. There's the week indicator, suggesting inactive phase, easterly anomalies going for a week. And then here comes our active phase, a two-contour active phase, forecast for roughly, we'll say, a week from now and holding into the first week of April, with westerly anomalies associated with pushing south of California somewhere in the last week of March, the first part of April. This would be your target for rainfall. This is your target for swell production. And then finally, and I say never believe a model going out more than a week, but we're going to go look at a model that goes out 3 months. Actually, this model has done a reasonably good job, all said and done. Now, this is past performance here. Forecast is here. This is the CFS model. 850 millibar zonal wind anomalies. Dateline runs right up the middle. Far West Pacific starts at 125 west, so here. So the Kelvin wave generation area, the all-important area, goes from about here over to about here. Blues are easterly anomalies, yellows westerly anomalies. So looks like we're in the inactive phase of the MJO for about a week, maybe a week and a half, according to this model. And then we have westerly anomalies setting up. Now, this is the really interesting part. Starting about a week and a half from now over the Kelvin wave generation area and continuing nonstop into June. Now, does that mean there'll be surf into June? Well, no, probably not. I mean, the seasons just kind of fade, and you know how it goes. But this suggests if there's this much westerly anomalies, this might, and typically during El Nino years, what I'm looking at is the development of nuking northwest winds along the springtime wind blow for at least North and Central California. And my guess is, during El Nino years, it typically doesn't happen. This El Nino hasn't been super strong and hasn't really followed the typical script. But with westerly anomalies, I think that would suggest that high pressure is going to be weaker than normal in the North Pacific, and that we have a reasonable chance of not just getting blown to death and get massive upwelling and all that stuff that happens typically during La Nina enhanced springtime periods. All right. Let's overlay the MJO, see if we're right. Here we go. Past active phases of the MJO in November, December with westerly anomalies, another one in January into February, and then our current inactive phase of the MJO. This suggests it may be holding for almost 2 weeks, but then the active phase of the MJO and westerly anomalies take over the Kelvin wave generation area. And a little bit of a blip here, but really, I think we could say maybe a continuous active phase from March 20th the whole way into May 15th or so. That'd be sweet if it happened. That would give us a big target to squeeze any last potential for moisture out of the atmosphere and swell out of the North Pacific before the inactive phase sets up in May and in early June. But even then, westerly anomalies are forecast. Let's overlay the low-pass filter. This really sort of paints what's going on here. The black is a low-pressure bias. The solid contour, the dotted line, dotted contour is high pressure. All right, the date line again, runs right up the middle here. So 1, 2, 3, 4 contours. This is your El Nino indicator. Fully in control it was back in January, weakening some in February and March, but still 2 contours forecast. Well, the third contour fades, I guess, about 4 or 5 days from now. The second contour holds into April 22nd or so, and still the El Nino signal persists even into June in the Pacific, with no sign of a high-pressure bias building over the equatorial central Pacific. That is good news. That said, now let's go look and see what's going on in the ocean. We look in the atmosphere, MJO looks good, but production of Kelvin waves? Probably not. I'm just going to say it right now. All right, we're looking at data from the TAO buoy array, that series of buoys strung across the equator used for monitoring El Nino. You can see these little X's here. These are the anchor lines on the buoys. The X's are sensors on the anchor lines. They are used to collect subsurface temperature data. Active phase of the MJO creates westerly anomalies in the West Pacific. This is the West Pacific here. And that, in turn, can take warm water that's here, start pushing it east in the form of a Kelvin wave. That Kelvin wave would follow the thermocline down about 150 meters across the Pacific. But right now, let's just look and see what's going on. This is giving us a temperature profile. The 30-degree isotherm, 30 degrees centigrade, well, it was over at 180, I think even 175 at one point. It is quickly retreating off to the west. The 29-degree isotherm, which was over at 160, is retreating to 175 west. The 28-degree isotherm, actually, it was over at like 150. It's making a little push off to the east here to 125 west. But I think that's more a function of warm water that was here getting caught by trades and pushed this way and just making the graph expand this way. The 24-degree isotherm getting steadily shallower. What is it, maybe 18 meters deep here? So not a very deep pool of warm water off Ecuador. But it is not the actual water temperatures that matter. It's the anomalies, the difference from normal. And this really paints the picture. Here is pretty much the thermocline, and you see nothing but cold water pushing the whole way across, following the thermocline across the Pacific, the whole way into Ecuador. This warm water above it, there's 1, 2 degrees centigrade anomalies here. This is the very last of the warm pool getting squeezed to the surface by this cold water that's pushing up and will eventually reach the surface. And there is literally no sign of any Kelvin wave development here. All this warm water that's here is the last of El Nino's warm waters off of Ecuador getting caught by trades, pushed off to the east, making its migration back to the West Pacific. We have another chart that paints the picture. Let me see if we can make this just a hair bit bigger for you. And it paints the picture even a little bit more starkly. You see nothing but cold water falling off of New Guinea. Under the dateline, the thermocline goes right down along here and then working its way the whole way up off the coast of Ecuador. You see the cold water surfacing at 120 west and also this area right off of Ecuador. This is the beginning of La Nina, and you see the last of the El Nino warm water moving off to the west and probably gone for quite a while. Cold water, the beginning of La Nina, setting up. Sea level anomalies, just another way to measure that data. So what are we looking at here? Well, there's New Guinea. Oh, that's Australia there, New Guinea there, the equator there. dateline there. This would be Chile, Peru, Ecuador, the Galapagos Islands there, Central America. This data is the height of the sphere of the ocean. Use a satellite, take a bunch of measurements, strip out the waves, the wind waves, even the tides. And is the sphere of the ocean higher or lower than normal on the equator, 5 degrees north and south of the equator? Why does that matter? Well, you can infer whether there is cold water at depth. If you have warm water at depth, well, warm water at depth expands. It'll displace the water above it and create a bump on the ocean surface. If you have cold water at depth, it contracts. The sphere of the ocean sinks in relation to that, and then one can infer you have cold water. And here you go. We have -5, -10 centimeter anomalies off of Ecuador and the Galapagos. And basically, what's this? 0 to -5, the whole way across the equatorial Pacific, the whole way into New Guinea. No sign of any Kelvin wave, no sign of any warm water, not unexpected. What is happening now? We're in recharge mode. All the warm water that was here is moving this way, going to start rebuilding over here, and that's the beginning of La Nina. Upper ocean heat anomalies. This is great. This really paints the picture. This is the West Pacific here, East Pacific here. If you've been following this channel back last year, we had all cold water here off the East Pacific, all warm water in the West Pacific. You can literally see 1, 2 Kelvin waves, 3, 4, 5, 6, 7, and even an 8th one down here or a 9th one. That was all the warm water driven by relaxed trades and westerly anomalies moving into the East Pacific. And then here you go. Here's your cold water Kelvin wave that has traversed the Pacific. And now right here, just poised to start impacting Ecuador and the first signs of La Nina. Real quick, upper ocean heat anomalies for the area from the dateline to a point beyond south of California. This was all warm water, massive amounts of warm water. This is starting in March of 2023, the whole way into December of 2023. And now here we are. This was the beginning of February. And this is not surface water. This is subsurface water. This is just showing the depletion of the warm surface pool in the East and Central Pacific associated with El Nino and the development of cool water in that same area, the arrival of La Nina. All right, let's go to the surface, not subsurface, ocean surface temperature anomalies. Chile here, Peru here, Ecuador here, Central America, Hawaii out here, Galapagos Islands here. The oranges and reds, warmer than normal temperatures. The last of the El Nino warm pool here off, as it typically is, off of Peru, Ecuador, up into Central America. But you also see a clear emergence of cooler than normal waters. Now this is 4 images. They don't overlay exactly. We got some other data here, but this is the high-res one. The emergence of cool water from the Galapagos the whole way out to a point south of California. The beginnings of that cold subsurface water starting to make its way to the surface. This image right here is the 7-day trend, sea surface temperature trend for the past 7 days, South America, Central America, the equator right here. Dateline right there. Clearly the blues is the emergence of this cool pool, so cold subsurface water starting to advect up to the surface. Yeah, there are pockets of warming here off of, let's say, Ecuador and Panama, that area. But this is the clear signal of the beginning of a transition from a warm surface regime to a cool surface regime. And then looking at the backed off view, again, you see just a little bit of cool anomalies here. You go, well, that's not so bad. Look at all this warmth. But give this some time. We know how much, it's literally subsurface-wise, it's cold water from here the whole way over to here. It's all going to start bleeding to the surface, then get caught by the trades and dragged off this way. The last of this warm surface pool is all going to start rebuilding up over here. This is where your low pressure, because you have warm water here, your low pressure rising air column will set up here. And because this is going to get colder, this will be falling air and high pressure. And that's the classic La Nina kind of setup. Now, this is kind of interesting. This is the Nino 1.2 index. It's not the official index. It shows temperatures actually up at 1.062 degrees above normal. It doesn't reflect any falling in sea surface temperatures. And the Nino 1.2 region is that area right there from Ecuador and the Galapagos out a little bit. I think most of the cooling is not in the Nino 1.2 region. That's why temperatures aren't really showing it yet. In fact, there's warming there right up against the coast of Ecuador, so it's negating whatever cooling is happening further off the coast. And this actually looks good. We go to the Nino 3.4 region. Temperatures today plus 1.069 degrees, so a neutral El Nino is half a degree, from minus half a degree to plus half a degree. Weak El Nino is from 0.5 to 1 degree above normal, and this isn't the official index, but moderate El Nino from 1 to 1.5 degrees. In fact, here's the official weekly data. This is Nino 1.2. This is Nino 3. This is Nino 3.4, the official El Nino region. This is Nino 4. Temperatures down to 1.3 degrees above normal. And you can see our peak temperatures here at 2.1 back in late November, 2 degrees into about the end of December, and then we've been on a steadily falling trend. So from a weekly perspective, what would this put us at? Let's see, weak, moderate El Nino from 1 degree to 1.5 degrees and falling from there. So our current El Nino, that we're still in El Nino, is fading. And here is yet another chart showing sea surface temperature anomalies going back to March a year ago. Warm emergence of El Nino off of Ecuador, steadily building in coverage, peaking out in, according to this, probably peak temperatures somewhere right around here in December, January, and then you see temperatures steadily warming. What do we have? 1, 2, 3 shades, pretty much in control now. 1, 2, 3. So 1 to 1.5 degrees, and we just saw that it's about 1. The official El Nino monitoring region is from 120 west out to 170 west, 5 degrees north and south of the equator. So we're about right on track at 1.3 degrees above normal. But you can see the trend is steadily downward. So what does the atmosphere think is going on? I mean, theoretically, one would say we should still be in El Nino. We look at the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. Darwin in the Indian Ocean, Tahiti in the Pacific Ocean. When pressure is lower in Tahiti, here's the two pressure, the index goes negative. Well, it's positive, 6.46. Okay, and sort of looking back here, it's been hovering around neutral, well, for a long time. And last really good negative push we had was back in mid-February. And from there on, it's just been steadily upward. Not surprising, this is the typical demise of El Nino, though this index was not a very good indicator of El Nino at all. It just didn't work very well. You'll see in a minute. The 30-day average, we're at minus 508. Yeah, we were down at minus, where were we, 18 or so, 19. Yeah, about minus 19.36 here in February 20th. Steadily going up from there. This is the 30-day average is good for your MJO indicator, active inactive phase. So this would have been at the peak of an active phase here, going into the inactive phase. And now the 90-day average would be your El Nino La Nina indicator. Today, minus 4.54, basically neutral. And you can see we never really went that deep. I think there was some pressure anomaly going on in the South Pacific that kind of negated or muted the impact of El Nino on this index. Let's go look at a 30-day graph. Here's the 30-day moving SOI graphed out. Here was our La Nina back in 22, and then the beginning of El Nino in 23. Positive numbers fading, dropping. This looked really good as we got into June of 2023, and then there was this weird thing that just went on. Not only did it do here, and we went back to almost like a weak La Nina, but just atmospherically, our El Nino kind of stalled. It tried to regather itself as we got into the fall, a push of fall, got the index down, periodically down to minus 15, but the reality is we should have been down at minus 20 or 25 and holding. And look at this. In the supposed peak of El Nino, we were up at plus 9 or plus 8. I mean, the likely theory is that the PDO, another even longer running oscillation, a 30-year oscillation, was deeply in the cold phase. We think that really sort of took some of the energy out of our El Nino, and that was reflected here in this index. And some other places, you can talk and go, well, was this really an El Nino winter? I would have thought we would have had more storms, stronger storms, bigger surf. We had it at times, but it wasn't as consistent and persistent as one would have thought. And I think the PDO was the culprit. And then some people say, well, climate change is really driving the PDO, and the PDO, because it's been in the cold phase for so long, that maybe is attributable to climate change. I don't know. We've been in the cold phase of the PDO since 1998. So that's what, 26 years already now. And typically the PDO goes in like a 25-year cycle. We'll see. If it changes, then that's great. But if the PDO stays cold, and I'm not going to get into that tonight because we're too deep into this already, but that is a thing that we might explore in a future video. And finally, the sea surface temperature forecast from the CFS version 2 model for the official El Nino monitoring region, the Nino 3.4 region. Here was our peak sea surface temperature, 2 degrees back in December, steadily falling. The projection starts right here. This would be, somewhere about the early part of March. You see it just going off a cliff, going supposedly down to minus 2.45 degrees in the fall. That would be an extremely strong La Nina. Here is another, more moderated, the PDF corrected version, saying temperatures may be only falling to 1.5 or 1.65 degrees or something like that, which is still definitely La Nina, but not nearly as strong. We looked at 2 videos ago, the consensus forecast. In about another 10 days, that will update. It only updates once a month, but it shows you every El Nino forecast from every model there is. The point being, it's kind of early to know too much what's going to happen. We're not even in spring yet, and the spring unpredictability barrier, there's things that happen during spring that can either really dampen the formation of El Nino or La Nina, and you don't come out of it till the end of May, early part of June. So these are just rough stabs by a couple of models. We'll know a lot more about 3 months from now, but it certainly appears by all empirical evidence that we're heading towards La Nina. Irrespective of that, for right now, we have the active phase of the MJO trying to build, or forecast to build, the Jetstream forecast to consolidate, a series of gales forecasts. In fact, solid swell is already starting to develop and hit the outer buoys off of Northern California, and it looks like there's a whole bunch more behind that, with the active phase of the MJO set to continue the whole way through the month of March. So it seems like there's a big red X on storm and swell production for the rest of this month. Make the most of it while you can. Now, in regards to snow production, that's probably not so good. When the jet stream consolidates and pushes east to a point north of Hawaii, that puts the split part of the jet right over top of California and puts high pressure in control of California, and probably wouldn't do a whole lot for snow production. It's actually when the active phase is not in control and the jet stream super splits over the Pacific, that it actually allows the northern branch of the jet to dip down over California, like what we just had, that big blizzard, and that ushers in cold air. And there's still piles of moisture in the atmosphere, one from that volcano that erupted under the ocean surface, Tonga, was it 2 or 3 years ago, combined with the moisture that El Nino puts in the atmosphere. There is lots of moisture in the atmosphere and supportive of rainfall production, let's call it that way. Even into next fall, we expect that we'll have a pretty good, in fact, it's pretty common, the year after El Nino, you get just tons of snow into California. So for the moment, I'm not too worried about snow and rainfall. We've had a normal year this year. The year before was off the charts. If we get that again for this coming year, we'll be in good shape. Now, the one concern is folks that are in New Mexico, Texas, that area. Some of you viewers have written in and go, we're still really dry, and yeah, you are. The Colorado Basin is way below normal. This El Nino, again, we thought it was just going to tear right across the southern tier states. It didn't do that. We think that's related to the PDO thing that we talked about earlier. So we're hoping, fingers crossed, that there is some sort of precipitation coming over next winter. If not, things are going to get very drastic for southern tier states. Not so much California and Nevada, and I think they're in good shape and will continue to be in good shape. But further inland, things could get pretty tough. We'll explore that more and keep our eyes on that. But from a surf perspective, looks like surf is on the way. Make the most of it while you can. Maybe we'll get lucky and get a little bit of snow as we get into the latter part of March, early part of April. But after that, it's going to be over. All right, that's the video for this week. I hope you enjoyed it. If you did, give us a thumbs up. If you have not subscribed, please click the Stormsurf icon down in the lower right-hand corner of your screen. That'll get you all signed up. And if you'd like to donate, you may use the special thanks button down below, the heart with the $sign on it, and give us a tip. We'd appreciate it. Other than that, we will do this again next week, same time, same channel. Thanks for watching.